Gravity walls versus cantilever walls. Which is better? Welcome to Blueprint to Reality, the channel where civil engineering concepts come to life. Today, we're comparing two of the most widely used types of retaining walls in construction, gravity walls and cantilever walls. Which one is better? Well, it depends. In this video, we'll break down how each works, their strengths and weaknesses, and when you'd choose one over the other. What is a gravity retaining wall? A gravity wall relies entirely on its own weight to resist the lateral pressure of the soil behind it. These walls are typically made from concrete, stone, or masonry and are quite thick at the base. Their design is simple. The heavier and wider the wall, the more resistant it is to sliding, overturning, and bearing failure. Gravity walls are often used for shorter wall heights, usually up to 3 meters or so, unless they're built in steps or reinforced. What is a cantilever retaining wall? A cantilever wall, on the other hand, is a reinforced concrete structure that uses a vertical stem connected to a base slab. The base consists of a heel, on the soil side, and a toe, on the exposed side. The design takes advantage of lever arm action, where the weight of the backfill on the heel helps counterbalance the soil pressure pushing on the stem. These walls are structurally efficient and can retain higher walls than gravity walls, often up to 6 meters or more. Design principles. Weight versus mechanics. Gravity walls work purely by resisting force through their mass. More weight equals more stability. There's little reinforcement, and the shape is usually trapezoidal to lower the center of gravity and increase resistance. Cantilever walls rely on reinforced concrete and moment resistance. The structure transfers lateral loads into vertical reactions at the base. The base slab and the wall stem act like a beam fixed at the bottom. Reinforcement steel handles tension zones, allowing the wall to be thinner and lighter. Construction materials and cost. Gravity walls can be made from stone masonry, concrete blocks, or mass concrete. They're simple but require a lot of material, which increases cost for taller walls. Labor is relatively easy, especially with modular blocks. Cantilever walls require formwork, reinforcement, and good quality concrete. Though they use less material overall than a tall gravity wall, construction is more technical and labor-intensive. Formwork and curing time can add to construction complexity and cost. Foundation and space requirements. Gravity walls require a wide footprint. Their base must be heavy enough to prevent tipping and sliding, which means more land is needed behind the wall. This can be a problem in space-constrained sites. Cantilever walls have a narrower footprint and need less space overall. However, they require proper soil-bearing capacity and sometimes need foundation preparation to prevent settlement or shear failure. Drainage considerations. Both wall types must handle hydrostatic pressure. Gravity walls can incorporate weep holes or gravel backfill easily. Their mass helps resist water pressure. Cantilever walls need carefully designed drainage systems, weep holes, drainage pipes, and filter fabric behind the heel to prevent pressure buildup that could cause structural failure. Inadequate drainage is one of the most common failure points in cantilever designs. Performance and durability. Gravity walls are durable and stable, especially when made from masonry or stone. They resist weathering and don't rely on steel reinforcement, which can corrode. Cantilever walls, being made of reinforced concrete, can suffer from steel corrosion if not properly waterproofed or if exposed to harsh environments. However, when properly designed and maintained, they are strong, long-lasting, and efficient. When to use gravity walls. Gravity walls are preferred when wall height is low, under 3 meters. Local materials like stone or concrete blocks are readily available. Site has ample space for a wide base. Aesthetic appearance is important. Stone masonry can be visually appealing, or you want a simple construction process without much reinforcement. When to use cantilever walls. Cantilever walls are ideal when retaining height exceeds 3 to 4 meters. Space is limited and a compact footprint is needed. Soil pressure is high and efficient load distribution is necessary. You need a taller wall with less material than a gravity wall would require, or a long stretch of wall with consistent design is being constructed, like for highways or commercial projects. Cost comparison. Initial construction cost. Gravity walls tend to be cheaper for low heights due to minimal design and no reinforcement. However, they get expensive quickly as height increases due to increased material use. Cantilever walls are more cost-effective for taller walls as they use less material and are more structurally efficient, but require skilled labor, formwork, and more detailed design. Maintenance. Gravity walls usually require little to no maintenance. Cantilever walls may need inspections to check for cracking, drainage issues, or corrosion. Summary. Which is better? So, which wall is better? It depends on the context. Use gravity walls when you're dealing with short heights, need a simple and durable solution, and have room for a wider base. Choose cantilever walls when height, space efficiency, and structural performance are critical. Each has its place in the engineer's toolbox, and understanding their strengths and limitations is key to making the right design decision. Conclusion. That wraps up our comparison of gravity walls versus cantilever walls. Both are essential retaining structures, each suited to different engineering needs. Remember, there's no one-size-fits-all in civil engineering, only the best solution for the given site, load, and budget. If you enjoyed this breakdown, hit subscribe for more no-visual, straight-to-the-point structural insights from blueprint to reality. Until next time, keep building smart.